Okay. Assalamualaikum and very good evening, everyone. Especially to my fellow friends. Today we will present our mini project, which is our main focus is Mesocarp fiber. Okay, next. Okay, before we start, we would like to introduce ourselves first. And my name is Ahmad Azim bin Abdul Razak. My metric number is 213032.
My name is Muhammad Ifah Hakimi bin Mozaki, and my metric number is 20655.
Boleh dengar suara Irfan ke? Aku tak dengar suara dia. Boleh. Okay, hi. My name is Nur Asfar Afifah Sheikh Aziz. My metric number 212098.
Okay, next. Alright, so let's start with some introductions. As we know, Malaysia's palm oil is a one-off industry that be a major contributor to Malaysia to the country's GDP through the production of palm oil, which is a major edible oil. This industry also has already generates a large amount of biomass and agro-industrial waste, posing both environmental issues and potential for sustainable growth. Our main focus, which is Mesocarp fiber, is the fibrous material left over after the oil is removed from the mesocarp of an oil palm fruit during milling. This biomass also is produced from the fleshy section of the oil palm fruit that surrounds the kernel. And this biomass typically accounts for 10 to 15% of the fresh fruit bunch weight, FFB weight. And it is commonly used as a boiler fuel within the mills to generate steam and electricity, helping reduce fossil fuel dependency. All right, next. All right, let's move on to the composition and the characteristic of the mesocarp fiber. Okay. Mesocarp fiber is made up of fiber material, cracked kernel fragments, and milling detritus, which is one of the major byproducts generated during palm oil extraction. As I said just now, this biomass has a residual oil concentration of approximately 5 to 6% on a dry basis. It also has potential for conversion into value-added products such as biofuel, biocomposites, and agriculture substrate because it has high lignocellulosic content. The large scale production of mesocarp fiber presents both a challenge and opportunity while it is bulky, moist, and hard to transport. Okay, next. Alright, so the environmental and economic impacts. Okay. In terms of environmental, the accumulation of these fibrous waste can lead to land occupation, increased risk of spontaneous combustion in storage piles, and potential release of greenhouse gases during decomposition. For the economic impact, the failure to utilize mesocarp fiber represent a loss of potential renewable energy and raw material that could offset fossil fuel use and reduce production costs, and it will reduce the production costs. Moreover, improper disposal can result in pollution and regulatory penalties affecting the sustainability credential of palm oil producer. Okay, that's all for me.
As far as next slide.
As
Next slide.
for next slide.
We continue for the current utilization in Malaysia. Currently, the utilization of Mesocarp fiber in Malaysia is still quite limited and mostly focused on minor application. Firstly, one of the more common minor issues used is the extraction of palm pressed fiber oil or PPFO. The oil is recovered from the fiber and can have value added uses. Secondly, there is limited application in soil amendment or composting, but this is not widely practiced due to logistic and technical challenge. And third, Mesocarp fiber is also used as a growing medium, particularly in banana cultivation and tissue culture process. Besides this, there are early stage of research and development focused on two promising areas in bioplastic and biocomposite. Next. All right, for the challenge in utilization, for the first challenge is bulk and fibrous structure. It's not easy because it takes a lot of space and not easy and cheap to move because mostly the microscrap fiber is they are just put in at the area mills, and second is high moisture content. Over 40% is moisture content, which make it burn poorly if used as fuel. And third is impurities. It has like fatty acid and dirty, so you can just use it directly in food or comestic. And the last one is the quantity is constant. It depends a lot on how fruit is processed and where it's grown. And the biggest problem for industry that need suitable raw material. So that's all from me. Next, I pass to Asfa.
All right, thank you, Hazim and Irfan. So next one is good day. Next one is about future recommendation. Okay, as we explore the role of Mesocarp fiber in waste management, I believe we must also ask what's next and how can Malaysia turn this agricultural waste into economic opportunity, right? Okay, firstly, we recommend the development of centralized biorefinery system located near palm oil mills. These facilities can integrate advanced technologies such as supercritical carbon dioxide extraction and pyrolysis. This combination not only allows us to recover valuable oil and antioxidant from the fiber, but also convert the remaining biomass into biochar and bioenergy, supporting both agriculture and Malaysia's renewable energy targets. Okay, the second one is public-private partnership, which is next. We propose collaborative pilot project through public-private partnership, and with government incentive and private investment, the industries can scale up innovation faster, making sustainable solution financially feasible for palm oil producer for all size. To maximize returns, Mesocarp fiber should be valorized into a wide range of ends product, and this include bio-based plastic for sustainable packaging, nanocellulose for food, cosmetic, and filtration industries, and the last one is biochar to improve soil health and carbon sequestration. Okay, in regarding integrate ways to resource strategies into all palm oil operation, we also emphasize the need for policy reform that encourage circular economy models and training program for plantation workers and engineer to manage and process biomass efficiency. And with the right combination of technology, policy, and education, we can elevate Mesocarp fiber from an industrial byproduct into a national asset. Sorry, a national asset. Okay, the last one is conclusion. To summarize Mesocarp fiber, this is a significant agro waste from the palm oil industry. Although it is commonly used as boiler fuel today, it possesses far greater potential in sustainable development. If properly managed, Mesocarp fiber can support environmental production. Sorry, this one is, yes, environmental protection by reducing methane emission, economic resilience through the product of bio-based product, and energy sustainability by replacing fossil fuels. So, in conclusion, to turning agricultural waste into wealth is not a dream, it's a direction. And with innovation and collaboration, that direction can start now. Okay, that is only I can conclude from the Mesocarp fiber.
All right, thank you to Asfa and Ifanakimi, and that's all from me. Thank you.